Okay, here's a video on how to do division problems. In other words, how to find quotients when dealing with exponents. I've got two examples right here that hopefully you'll be able to do by the end of the video. But before we go there, I'm going to suggest one thing. I'm going to suggest that you go back, and if you haven't already, watch my video on multiplying involving exponents, or in other words, finding products with exponents, because you need that information before you'll be able to do these. So before we can do these problems, I'm going to flip over to the back, and we're going to illustrate the idea. And I'll just start with the example of 2 to the 7th divided by 2 squared. And so we can see the rule, in other words, so we can find how to simplify this. The pattern usually comes out when we write these expressions as repeated multiplication. So I know that 2 to the 7th is the same thing as 2 times itself, 1, 2, 3, 4, 5, 6, 7 times. And then 2 squared is going to be just 2 times itself twice. And now that we're here, we're going to realize that there's a bunch of values that can cancel, or in other words, divide to 1. Because 2 divided by 2 is 1, so we don't really need to write that. And 2 divided by 2 is 1, so we don't need to write that either. And what we end up with is 2 to the 1, 2, 3, 4, 5. And so some of you are probably looking at this and you've already caught the pattern. You said, okay, well, if I have a value being divided by another value, they got the same base, because these are both 2's, right? Then I can just subtract my exponents, and that's going to leave me with 2 to the 5th. So if we were to write that algebraically, I could say x to the a over x to the b is equal to x to the a minus b power. So once again, don't be intimidated by the algebraic representation, but a certain base raised to a power divided by that same base to the power means we just are going to subtract those exponents the same way we do here. So hopefully I don't have to write out this repeated multiplication every time. We can jump straight from this representation, do 7 minus 2, and end up with this equivalent value. So with that in mind, let's go to our examples over here. We'll work through this example first. And so in this example, I've got a product up top, and then all being divided by 5 to the 7th power. And so in order to simplify this, don't be intimidated by the whole problem. Let's just take it in baby steps. If this was my problem by itself, we learned in my previous video that I'm just going to add the exponents. That would be 5 to the 4 plus 8, or in other words, 5 to the 12th power, all over 5 to the 7th. And then as we just learned on the other side, I've got the same base in my numerator and my denominator. And so what I can do is I can just subtract those, and I end up with 5 to the 5th power. So this expression, if I simplified it, would be 5 to the 5th. Now, this next example is pretty tough. And actually, before we go there, I'm going to come down a little bit and mention another idea that's going to be important here. If I have a whole fraction raised to a power, let's take, for example, 2/3, and let's say I have that whole value squared. Well, I can write that as repeated multiplication as 2/3 times 2/3. And I know that 2 times 2, when I multiply fractions, I go straight across. So 2 times 2 is 4, 3 times 3 is 9. But I'm going to write those in exponent form to see the pattern. So what we see is I have a whole fraction raised to an exponent. That exponent is going to apply to my numerator and my denominator. Or, once again, to write it algebraically, if I had x over y to the a power, that's the same as x to the a over y to the a. Okay? Now let's keep that in mind, kind of look through this lens as we look at this problem. I've got a fraction all being squared. So I'm going to take that and I'm going to apply the exponent to the numerator and denominator the same way that we did in our example down here. So I've got x squared to the second power, x squared to the second power, over 4y to the second power. Now, once again, this is a throwback to my previous video about how to raise a power to a power, but in that situation, I'm just going to multiply exponents, so my numerator becomes x to the 4th. In my denominator, if I have a value being multiplied and the whole thing is raised to a power, once again, this is a reflection of my previous video, that's the same thing as applying the exponent to both. And so I end up with x to the 4th over 16y squared is going to be my most simplified form of this. Now, it's important to keep in mind that we can't subtract any of these exponents because our bases are not the same. I have x in my numerator and y in my denominator, so we can't do the same process that we did in these previous ones. So once again, if you can do these two problems, you've pretty much mastered this lesson. But the two main ideas, first off, is that when I'm dividing numbers with the same base, and they both have exponents, I can just subtract those exponents. And then another important idea is that whenever I'm dividing a value, or you can look at it as a fraction, that whole fraction's raised to a power, I can apply that exponent to my numerator and my denominator.